Hello, everybody, and welcome to the ODTN use case meeting for this week. As usual, the call is recorded and will be shared on YouTube. So thanks everybody for joining. A few updates on my side. I don't know if Kingston is on the call, but Kingston from PLC Networks volunteered to do an OpenConfig driver consolidation. As we will see, there will be two new drivers that are going to be added as of basically the next 1 or 2 weeks. So and the code is mostly the same as the existing ones. So thanks to Kingston and PLC Network, what they will be looking at by the end of the year is taking a consolidated approach to these drivers, as we discussed in the previous calls. So the idea is just to have one with very minor changes on a per device basis and not have major duplication of code that is hard to debug and maintain. So that's the update on the OpenConfig driver consolidation. I'm gonna have a call with Kingston tomorrow about this specific tasks, and I encourage everybody who wants to join the discussion to be available in the upcoming meetings, because we'll probably present a plan that Kingston will be putting together. Another update from my side is that I am in progress for releasing a video update of the demo that we did at ONF Connect. I have the ONF side recorded, meaning the Cassinis, the grooves, and the momentum modems. I still have to record the Telefonica side. My hopes are to do it tomorrow. Unfortunately, I have been having a lot of other stuff to do, and this is not really been a high priority for myself. But the video is almost ready. Will be shared probably with an updated blog post about the current status of the work that I'll share with everybody, and I'll put together. So that's the update from myself. Next up, I want to ask Jan, who's on the call, about any update on the integration of the checklight ROADMs with ONOS, if there is any. Jan, I seem not be able to hear you. Jan? Okay. Can anybody try to speak so I can make sure that my audio is working and it's not on my side?
Andrea.
Oh, hey Arturo. Okay, then it's not on my side.
Peter's working.
Okay, I think it's working. Okay, thanks. Then I'll defer Jan updates as soon as he fixes his mic or rejoins. Next up is a Nokia Power Config update. So thanks to the effort of Ivan, who works with Dominique within the Nokia team, there is a patch for the Nokia transponder that adds the power configuration for that device. It's usual same old code that has been used for other transponders such as the Groove, such as the Cassini. This one, just please go take a look at it. But as you will see, there's a lot of duplicated code in there. And that means that we will get this merged, and then it's going to be part of the refactoring that, thanks to PLC Network, it's going to happen. But through this, we can achieve the same results of reading the input and output power. Current input and output power on the Nokia transponders is also set the power config on the Nokia transponder 2. So thanks Dominique and Ivan for the work that you guys have been putting on this. I'll take a look. It's been uploaded a few hours ago. I'll take a look as soon as I can. But I think there is no major issue in merging it. So with that, we'll augment our capabilities of doing power configurations on the transponders too. Dominique, do you want to say something about it?
I will leave Ivan to comment on that.
Okay, hello, it's Ivan there. Well, from my side, I can say that, yes, as Andrea said, there is a lot of, let's say, inspiration from other codes, but I also reworked some stuff and debugged it as well. So by now, code is stable, at least it works stable, and I need to do some check style stuff and just to clean the code more properly. And I guess that will be all right. So that's it.
Thanks, Ivan. Yeah, I think that what we will try to do is to keep the same boilerplate code in the consolidation of the drivers. We will keep the same boilerplate code together, like the get session and the most of the open config driver, and then we will leave the parsing of the values to the vendor because that's more specific to it. And if there are bug fixes that are portable across many implementation classes, we will port them. So that's good. Okay, thanks for the update. While you're on it, can you also give us an update on the command to achieve the cross connect? I know that is not fully ready, but if you have any update on that too, that would be great.
Yeah, sure. I freezed a bit the development of the CLI command because I was working mainly on other stuff these days and finalizing actually the power config. But I will return to this development in a few days.
Okay, thanks, Ivan. It's great news. Okay. While we are on the driver matter, thanks to the effort from the ADVA side, in particular Jakub, we now have a fully compliant phase 1.5 driver for the ADVA transponder, again based on phase 1.5, phase 1.0, which is already there, and based on OpenConfig. So the patch is up. I still have not got any time to take a look at it, but it enables to do wavelength, power, and it changed a little bit of the port discovery, because that is very important, at least from our perspective, to achieve proper port discovery. So again, if you have the time, take a look at this. Perfectly aligns with what other drivers are doing. And again, there's a lot of duplicated code. Like if you take a look just at the number of lines for this, it's 465. And what we were discussing before, it's 489, meaning that most of the code is duplicated for the power config between these two. But I think what we will do is that we will get them in since they are working, and we will then refactor, and when the refactor comes, we will ask everybody to do a test with their devices to make sure that it works. So thanks Jakub for taking care of this. It's been very good to have it, and thanks Stefan for the contribution from ADVA. Anything from your side, Stefan?
No, not really. On that one, yeah, like great work, and yeah, thanks.
Okay, that's good. I think it's a good milestone also for that. Perfect. So this is being the update for the different drivers on the transponder side. Jan, I hope you fixed your mic problems, and you can give us an update on the ROADM integration.
Hello, same here. Can you hear me?
Yes, perfectly fine.
Okay. So the thing is, we started creating the setup in the lab, putting all the hardware together, and so we are on a good way, but we have not started working on the drivers at this time yet. So that's it.
Okay. As always, please do take any suggestion you want from the existing code base, and if you have any questions or thoughts about this, just drop me an email. I know Ivan here, which is on the call, could give you a hint, and I can also pull in Alessio, who's the main writer behind the Momentum Rodems, to give you a hand. So as soon as you start developing, you will face some issues and you will find some problems, definitely, in the sense that, as a first-time ONOS developer, it's not that, for drivers, it might be a little challenging, but, just let us know as soon as you start and we can give you a hand on that side. But it's good that the hardware is being put together. So pretty good. Thanks.
Oh yes, thanks a lot, and thanks also for your work on that Cross Connect for ROADMs. I expect that this will help us real a lot. So thanks for it. I'm happy to see the work. Thank you.
Yeah, I think that we will have it ready with Ivan as soon as it sooner than when you need it. Let's put it this way. And there are other ways to test it, but I think that command will simplify just ROADM testing. So that's pretty good. Okay. The next element on the agenda, before I go and present a little bit of advancements on the GMPI integration, is the FEC and bit error rate work that Sterlite has been doing. Vishnu, is there any update? I thought Vishnu was on the call, but apparently not. So I think that there is no real update from last week. What I did is that I ported all of these stories to the Jira board that you see here. So as soon as we merge the patches, we're gonna move them and merge them. I also have in the pipeline, thanks to Suraj, an update for phase 1.5 and a rebase of the existing drivers on top of master for the Fujitsu transponder. So that's coming along the lines too, which is good. And I hope to get that done before we start reworking the whole drivers. I added the bit error rate workflow for Sterlite. And the checklight ROADM, the open config consolidation, the bit error rate effect, and stuff like that. So if you want, if you have an ONOS account, you have access to this board. I'll just copy the link in here. And if you do some work, just please do make sure that you give an you update your task on Jira, so I keep track of it and I get notifications about all of that. So that's pretty good. So the next major step, as you guys all know, is the integration with GMPI. So we had a very good call last week with the GMPI team and the TIP group, and out of it, it spurred a presentation about the demo that we plan to do at TIP Summit. I'm just going to go through it, and if there are any questions, just do let me know. I'm going to concentrate mainly on topology and the workflow, the demo workflow. The idea is to have 2 Cassinis, a few checklight ROADM nodes, and ONOS talking with GMPI, plain old topology. And for an implementation perspective, we spoke with Esther from Orange and the remaining GMPY team, and they said that it's feasible, the approach that we want to take, which is pre-provision the topology to both ONOS and GMPI, then ONOS be the master of connectivity requests, that then in turn turns to GMPI, giving the path information. GMPI computes the OSNR value, gives back the list of paths, including the list of devices, OSNR, wavelength, and power, and then ONOS selects the best one. There is still debate if this selection has to happen inside GMPY or in ONOS. There is already a piece of code that does that, which is living inside GMPY but is not being merged, but we'll see. That's something that the work will distinguish, and then ONOS installs it. So we went back and forth with the GMPY team, and maybe Jan can comment also on this. But the idea is that the GMPY already has a set of APIs that we can use for this. In particular, there is a REST API that can be used to request and get a response. The current request response is the following. I have two examples here. So in the path request, what you can send is basically an ID. That's fine. That's something that we need to agree upon. The name of the transponders, which needs to be repeated in 2 fields. Bidirectional flag. This one we will set it to true for sure, because what we want is a bidirectional end-to-end path. And then we want the type of grid. In this case, for us, this will be WDM. This will probably be Cassini, since that is the transponder type that we have. We will not fill the mode, which is probably going to be 200G, if that is correct. So this, I don't particularly know exactly what this slot is. So if Jan, you have any ideas of what this is?
Yes.
I'd appreciate it.
So this refers to the ITU definition of flex grid, which unfortunately does not work directly with a range of frequencies or a center frequency and a channel width, as in gigahertz or megahertz. So there is some small indirection M and N. They're defined in these usual multipliers of 12.5 gigahertz or 6.25 gigahertz. So it's just a slightly different but ITU compliant representation of frequency. That's what ITU people came up with, and IETF has been apparently aligned with this for years. So that's why it's also here in the API.
Is this the frequency range, minimum, maximum, and minimum frequency that you can set on a port? Is that what you're?
No, it is one specific channel, and GNPy. So the short story, just leave it as it is, and GNPy will tell you what frequency to use. That's probably the easiest option.
We can leave it to null.
I think it's N is a nominal central frequency. This is the center of the frequency slot. And M, in fact, is a number of slots, usually a number of 12.5 gigahertz slots that you have, because this is basically the granularity of the frequency slots, 12.5 gigahertz, and the granularity of the nominal central frequency is 625 gigahertz. If we reference the ITUT 694.1 recommendation. Is it right?
Let's say I will investigate this with the team and see exactly what it means. But if it can be left to null and GMPy can tell me the wavelength to use, I'll probably do that.
Yes, I think you can maybe put in comment ITUT 694.1 recommendation, and you will get the definition of the N and M value.
Thank you. I'll take a look. Then, well, spacing again, hertz. We will use the 50. We are using the 50 gigahertz grid, so that's no problem. I'll leave these two to null, and this one I'll probably leave it to 0. In order for them to ask to do that computation. Hey, Jan, yes.
Yeah, apparently my audio issues are back. So yeah, what Dominique was saying is correct. This is about flex grid and specification of frequency range for one channel. Yeah.
Okay. Yeah. Then, so this will be the request that ONOS will generate. I think it's pretty straightforward to generate this out of ONOS. It's a JSON file. It will be just one path request, fairly straightforward, no real problems. And then what we will get back is a response which contains well, the ID, which, if I'm not mistaken, is matched to the request ID, and the SNR value, and a set of, well, the bandwidth, which is something that we will probably use. At the moment, we only use 100G. 200G channels. We might take a look at using 100G if this sets us 100G. Then it gives us a path of root objects, which are node IDs. These will be translated back into ONOS device IDs. So in this way, ONOS will know which path to pick across the network. I do not particularly know what this transponder mode 1 is.
So this is for switching between different modes, as in, so a mode is essentially a combination of modulation and baud rate and symbol rate.
I see. Okay. Who does specify these modes?
So these come from the datasheet of the equipment. I think that Cassini also supports, from the top of my head, at least 3 of them, because they are using the same DSP unless I'm mistaken, which means 100G, 150, and 200G on either 1 or 2 carriers. So yeah, you will get back an answer which maps to a name of configuration to provision on the transponder.
So this needs to be mapped within ONOS to a certain modulation, for example.
That's right. Or we can always cheat and we can configure the demo to say that there is just one mode that is supported, and then you could ignore this parameter.
I think that ONOS has the capability to do modulation settings, so I think that's fine. Maybe some other parameters would be ignored, but for at least the ones we have, I'd like to use them. The other important value is this. I think that the power is this reference power, and this reference power is the power at the ROADM side. Is this correct, Jan?
I don't know, but I think so. Yeah, I don't know.
Okay, then. Okay, then I'll use that. So basically, out of this, which, by the way, this is probably missing the wavelength, meaning that somewhere in this response, we should probably get the wavelength.
It is in there. It is in the middle. That's the yellow label hub. And so think of N as an offset from the middle of the C-band. And yeah, that's the same N and M as before. This is IDU.
Yes, correct. I have a small naive question. The transponder type Voyager, this is from this is a vendor type, transponder type from a vendor, right?
So this is essentially a pointer to a thing. So what GNPy needs in order to compute the performance of the signal is essentially a large heap of data sheets, right? And we call it equipment library. And within the equipment library, we are gathering performance parameters about EDFAs and also transponders. And so this is just an internal name which we have within the database that's internal to GNPy.
Okay. Okay.
I guess it would be Cassini something for the demo.
Yeah, I think this is just a mapper between how basically GNPy goes and fetches data from its internal store about a certain transponder. That I think that's really it. It's just that needs to
That's
be.
right. Yes.
Yeah. So basically, what I will probably do here is that I will, which is actually here. What we will do, since we are provisioning the topology from outside, we'll provision the topology in a way that the name of the devices will be the same within ONOS and GNPy. Make this clear, and then what ONOS will use is that the device name here, and that device name will be the same one which we will get here.
Okay. Okay, I understand.
So I think that's kind of it. So if I'm not mistaken, then, and please correct me if I'm wrong, what will happen is that we will need to translate this label hop to a OCH signal in ONOS. Whatever, it can be translated to a certain terahertz, and then from terahertz to the OCH signal. Is that correct?
Yes, you're right.
I'm not sure that N and M will give you the OCH, the signal.
Oh, so
it will give you the central frequency, the nominal central frequency value, and the frequency slot width. But I'm not sure it will give you the signal information. I don't know.
well, the signal information can be computed out of the central frequency, the width, and the number of slots, right?
I think that OCH is just a name from a different layer, from ODTN layer, right? So this gives you a specification, or this gives you all of the parameters for a media channel to provision to the ROADMs, and also to configure the, I think it's called OTSI, the TX and RX laser on your transponders.
Okay.
Guess that helps. So.
Yeah. But point being, we need to find a way to translate it into a frequency in terms of terahertzes, because that's what OpenConfig requires on the transponder side. And then, as soon as I have it translated to terahertz, I can translate it to the internal ONOS representation of it, and just distribute it and stuff like that. So I think it's doable. That's what I'm saying. So the idea is to, at least the implementation plan from an ONOS perspective, to me, would be to now create a service that, upon receiving a request from A to B, goes, contacts GNPy, gives it the request object, gets back the response object, translates it into an intent and proper configuration. Meaning that what I'll do is get back this object, out of the path root object, compute the topology object of ONOS, compute the wavelength, out of the label hop, compute the modulation, and object and wavelength are going to be sent down through the optical intent, while the modulation and power will be done through behaviors for now. There is an effort to extend the intent subsystem to achieve the same result, to capable of configuring them without having an external component, but we have the APIs, we're going to do it that way, I think, for now. So I think this is the implementation plan. Are there any comments, any thoughts on this?
Yeah, maybe one more thing. We are still finalizing some details within GNPy. So this is an API proposal. It is based on some pre-existing work. It is essentially the same thing that was used for transport PCE from Open Daylight, which is awesome. And but it's also based on a draft which has been already reworked a little bit. So the structure might change, but the amount of information which will be returned is essentially the same. That's my first point. And the second point, given that we will quite likely have a triangle topology, either with 3 separate ROADM nodes or maybe with longer fiber or something, it's very likely that what we had in mind in terms of API interaction would be that we create if ONOS asked for within the request for 2 separate services, perhaps for this joint paths. We will share information on how to do that later. And the point is that you will get back.
I think Jan dropped. At least I'm not capable.
Yeah, we lost it. Yeah.
Okay.
Can't hear him.
So I think that his first point is a good one. We have a call with them. I think that we now have a great understanding of the parameters. If they could simplify at least the response a little bit for me, and instead of including this very opaque mode, they could include modulation. I would be better if they could include a better way of representation of the wavelength. That could also be good. But yeah, I think that it's just an API change. The functionality is there, and I can easily start working on the pieces in ONOS. So without finalizing this specific element, just put in place the structure, and then as soon as this is finalized, we can get it done. So yeah, you were saying?
Mm-hmm.
Yes. Okay. And the second point, I think, was related to the topology. I know that the topology is trivial, but I think that showing the interaction is the value here. While we could ask for disjoint paths, we could also ask for a certain we could also introduce like losses on one of the paths, so with attenuators or something like that. But I think that from a code perspective, it's the integration is the value, and we will obviously, as soon as you deploy it on a more complex topology, you will get a better run for your money, basically, because you will get proper, real results out of your topology, but the results, the code will not change. So I think that the value is really showing the integration within the code bases. And the other way of doing it could be an operator margin, but I think this is just a way of telling a story rather than the actual implementation. So as soon as we have the implementation, we can easily tell the story with a few minor changes here and there. Maybe Jan is back.
Hello, this is Jan.
Hey. So sorry, you were at point number 2, which I explained that is functionality-wise, it's an improvement on top of the work, meaning that the foundation of the work is the interaction, while how you demonstrate it is more of the demo side of things, which I think that the value here lies in the interaction. How we show it, it's not terribly fundamental.
All right, I just wanted to say that you will get 2 paths, and that it would be nice if the operator could pick one of them based on whatever criteria they choose. Thank you.
Yeah, okay. We can definitely make that happen in terms of it's an easy update to the code base that I'll be putting on from the ONOS side. Okay. Okay, I think that was the overview of what we plan to do with the GMPI integration.
I have a question, Andrea.
Go ahead, Dominique.
The index 1 for the label hop is n equal minus 284. Who decided this this value? Is it something set, defined, or?
Are you asking for the frequency allocation or spectrum allocation?
Yes, yes.
I think so. So this is code which is currently work in progress, but I think it's something like first fit.
Because if we want to match it with OpenRODEM indexed, as far as I understand, this is not exact. The index 1 of OpenRODEM is not an n equal 200 minus 284, but it's minus 280. So it's a 191 dot 35 terahertz.
Oh, so it's about the C-band boundaries then.
Yeah, this is a C-band boundaries. Okay, it might be, but this is okay. It might be also relevant to use an index that match with OpenRODEM. That's why in this case here it's open for OpenConfig, maybe data model. No, I would just, yes, please leave a comment to clarify why index 1 is n equal minus 284. Because I may have done also a bad computation quickly. So yes, if we can clarify that.
Okay, I will also ask Esther. I think this is just a configuration parameter, and it's picking up the first channel from a channel grid, and we might have widened it for some reason. Thank you for bringing it up.
Sure.
Okay. Yeah, we have a call later with the GMPI team to fix some of these elements. So yeah, we'll report next week about the status of the work. The work on the ONOS side is going to be probably done by me. I have not yet started. I'll start as soon as we start fixing and as soon as I have some time to put together some code. I don't expect it to be a major element. It's probably just a few hundred lines of code to make the request and the response, but that's really about it, I think. So yeah, I think this is a good step. Any other thoughts, comments? No? Okay. So at the moment, the topology that we have in at the TIP summit is this one. It's not going to be in the ONF booth. It's going to be at the TIP booth. So we can discuss with them either to extend it, but at the moment, this is the current topology. We can always look at the showcasing the integration on other type of devices and other type of both transponders and line systems. I'll make sure to put together a code documentation on how to use it so that people can start testing on their own. And actually, that's something that we need to I would like to have from the GMPI side is, and this is something that I need to work on with them. So a documentation on how to start GMPI, how all of those kind of things, how to provision the topology, because I would probably have to test it locally on my code base, and so I would like to have that capability. So that's about it. So I think that
yes, I think we should have something ready by the end of the week or starting early next week, perhaps. I hope, at least.
Okay. That's good. Please keep me posted, whatever you have. So that's good. Okay, so that was all on my side. I think there were. Yeah, you can take a look at the slides here and the pull request here that we mentioned last time. I'm still targeting a January 1st, 2020 release for all of these features that we're talking about here, meaning the drivers with the consolidation, the ROADMs, a little bit of the second bit error rate, depending on how much we get done, and at least an initial GNI integration. I was all on my side. Are there any other questions or thoughts that you guys want to discuss today? No? Okay, then if not, thanks everybody for joining. I'll keep you posted on anything related to this if it needs to be done during this week, or we can give an update on the work next week during our weekly call. Thanks everybody. Take care. Bye-bye.
Thank you. Bye.
Thanks. Bye.
Thank you. Bye-bye.
Thanks. Bye.
Bye-bye.